Good morning, and thank you for joining today's webinar from SPEC Innovations, AI-assisted modeling and simulation of standard operating procedures with Sopatra. My name is Liz Steiner, and I'll be the moderator for today's webinar. First, I'd like to go over some housekeeping. During the presentation, feel free to send us questions, and we will get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group, or through Twitter using the handle @SPEC Innovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now, I'd like to introduce you to our presenter, SPEC Innovations President and Founder, Dr. Stephen Dam. Dr. Dam has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an Expert Systems Engineering Professional Certification from INCOSE. He is currently applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send him any questions through the LinkedIn user group or send him an email to stephen.dam@specinnovations.com. And now I'll hand over the controls to Dr. Dam, and we will get started.
Thanks, Liz. Appreciate it. So this is kind of our agenda for today. I'll give you some background. There's actually quite a bit of background to talk about for the Sopatra. Then I want to get into the guts of how Sopatra really works. How does it actually do this transformation and analysis work? And then we'll do a short demonstration to show you some of the real ins and outs of it. And hopefully we should have plenty of time for question and answer. So background, so a little bit of background on this project. This started as a NASA STTR. That's a small business technology transfer project. And that's where a small business works with a research institution. In this case, it was George Mason University. And to take some research work and transition that into something that would be useful for, in this case, NASA. But also in general across the government. If you're not familiar with these programs, the purpose of them is to enable that transfer of the research so that they have products the government can buy and not have to maintain, right? Because if they're commercial products, then the government doesn't have to maintain it, and that actually reduces costs to the government significantly. So they provide a little bit of seed money for this, and believe me, it does not cover the cost of development, but it's a nice way to get started and get two groups together who really need to work together, which is the academia and commercial industry. So with that background, go into a little bit more. So standard operating procedures. So at George Mason University, they have a center for air traffic research called the Katzer Center, and they've done a lot of work over the last 10, 15 years in researching standard operating procedures, particularly for airlines. And so they were looking at, what really makes a good standard operating procedure. What tasks must be accomplished and in sequence, particularly the how long, the when, and under what conditions, who's responsible for each step and how each step is performed, or what the functions are for that step. And then how do you confirm that it's actually working, that it actually will work when you want to implement it, particularly in an emergency situation, as most of these things are going to be done in an emergency. So, and under a lot of stress and pressure, and with a variation of personnel skills. So a lot of times you don't know, how much somebody knows how to do something, how often they've done this procedure, how many times have they been through it. These are all things that are part of that research we did with the NASA, and of course following the work that George Mason has been doing. So if you've ever modeled operator tasks, and I've done a number of that over the years, where I've taken standard operating procedures, or in the military, we call them techniques, tactics, and procedures. So that's TTPs are a very common thing to use, and that's a very similar idea to an SOP. And so they can be very complex. And so you think about the the device to help, when somebody's had a heart attack, and to give that AED gives you that pulse to start the heart up. These are all the steps in that process. So if you've not had the training, using one of these devices is probably not really a good idea. Yeah. So the recommendation is to get the training. But particularly what's important is what things require long-term memory. So if you look at the graph here, and I realize you can't read any of the boxes, but we blew up the actors. So the top line is the displays on the AED itself. So those are things that give us the indicators of what's going on in the device, right? And then the control knobs and buttons on the AED are that next line down. Then you have the operator, and then there's a separate line for the operator's long-term memory. What are the actions that the operator is going to have to remember from that training they took to help be able to make sure they do this properly? And of course, you have the patient, the bystander, who might be involved as well, helping with the whole process. So as you can see, this is a very complex process, and modeling it, you can see 15 action steps. Okay, the operator actions, 8 of them are, you've got a cue, you've got something that will kind of jog your memory to say, yeah, I got to do this, or it's something. But there's 8 that require long-term memory. Now that's not good. and if even with these things where there are prompts, the prompts may not be obvious to the person if they're not used to it either. So again, these are things that are part of that. Now you take something as simple as this device is, and now talk about the cockpit of an airplane. And if anybody's looked into the cockpit of an airplane, it's pretty busy. There's a lot of stuff going on there. Even with the glass ones nowadays, there's a lot that's happening. So some of the problems we've seen with standard operating procedures, or George Mason particularly saw with standard operating procedures, are these. So missing imperative steps in the SOP due to some kind of automatic level of consciousness. How do I know that I needed to do something? I forgot the step, or the step isn't obvious in the SOP. And that happens a lot. What must be done is specified, but not when. How fast must something happen? That resulted in an accident by Turkish airliners in 1951. And these orange examples, by the way, are documented in a very nice presentation at the Katzer site. So the CATSR site. You can go to that site and look at their publications, lessons learned. And they actually document each of these events and what's going on and the specifics behind each one of these. So again, information required to perform the next step is not available. That's not race conditions. Information not available in a timely manner. That's basically a very common problem, right? Because if you're not really tracking these things very carefully, even and particularly with the software, you can create race conditions in the software that's trying to help you through this process, and that can be a problem too. Procedures cannot be included in time. Of course, that's always a big one. And then looking at the user interface cues. What are those? What are those cues? How easy are they to understand? How well clear they are? Is it something you're going to see? Per procedural training, of course, is often a problem. In this, you want to make sure. This is why the warfighters will train so hard. They work really hard to make sure that they know what the tactic, techniques, and procedures are that they have to execute. And so it's automatic to them. And of course, no procedure for the scenario that happens, right? And they have a scenario that was never anticipated. So there's a problem. And of course, that's lack of analysis, that people haven't done a sufficient analysis of the different possibilities. And of course, it's almost impossible to develop all situations, but we do a better job. Okay. And procedures across the system of systems are not compatible. Again, that can be a problem. It isn't always the aircraft, but the runway conditions and things like that go on. There was a fairly recent example of that, of some, who was it? Harrison Ford, I think, had a problem where he was coming into an airport and asked, well, why is there an airliner on my runway? It wasn't his runway. So, these are little things that can get you killed if you're not careful, and other people killed in the process as well. So the solution, we think, is modeling and simulation. We think if you model the processes in depth, and again, there's a very busy model. Again, this is just showing a procedure of all the different tasks that have to be performed for the standard operation procedure on airlines, engine out above maximum altitude. So this is a problem that, again, has been identified, but you see how complex this becomes. Now, so doing that modeling is great, but I've got to have some way to determine, does it make any sense? Is it working for me? Also, I have a problem is that most of these procedures are in a written form for the operator, which makes sense because the operator sees things that way. They don't look at things like a model. But how do I then transform those words into the model so I can do that analysis? That's where a lot of time and energy gets put today. So the objective of Sopatra was that, how do we automate that? How do we take and make it easier for people to take these written standard operating procedures, convert them into some kind of behavioral diagram that you can execute using simulation. And the simulation we have to execute this with is Monte Carlo, because of that variation in everything that is associated with it. There are decisions that might be in the procedure that have to be made, and those will have variances in time. Just how long it takes somebody to see, hear, and decide to do something has variance to it. On and on. So you think about all those things that have variance in this model. I have to make sure I understand it well enough and I can simulate it actively. So again, now you can see, again, here's where just modeling is insufficient. I've got to simulate it too. So that executable simulation is very important. Of course, now what we used for AI techniques is natural language processing. Okay, and we started this project well before the generative AI boom that's happened in the last few years. That actually did happen towards the tail end of our two-year STTR phase 2. And in that time period, we did quite a bit of research on the generative AI. People have been and should be somewhat wary of the generative AI, because a lot of those techniques will go phone home. So there's some cybersecurity issues and questions with those that are of concern, and those are being worked. But so again, generative AI isn't quite where we need it yet in terms of being able to behind the firewalls and made available in a way that you can feel secure in using it. And an airline procedure like these things, these are all very proprietary. The airlines don't want to share these with anybody, so they wouldn't want to put these out on an open chat GPT kind of a platform. So today, but in the future we will, and we are researching that. We are looking into those things. So just to let you know, this is just the starting point. So NLP, we actually tried several NLP libraries and found ourselves having to write our own NLP algorithms using regex and things like that to help us understand what was going on better and manipulate the information better. We actually did better with that than the standard libraries at the time, which were very expensive too. But the idea here is that if we can provide this ability to create these standard operating procedures from the text and then verify them using Monte Carlo, we can do that very quickly and easily. We can do configuration management and revision management of the massive models that get created from this, and again develop that executable simulation, Monte Carlo simulation of the model. Now, the fortunate thing, by the way, we did have a starting point, which we have InnoSlate. So, so just to let you know. So again, what's that need? Again, you can see some lists here of things we came up with for, we thought, NASA and some non-NASA applications. And there's been interest in each of these areas. In fact, during the development of the phase 2 of the analysis of the STTR, we actually did some International Space Station examples as well. But we had fire company examples, we had medical examples, all kinds of different industries that you might imagine being able to take and to try these different SOPs. So you can see where this could be useful in a variety of places. So it has real potential to it. One of our visions was to be able to use augmented reality or virtual reality to be able to view these things as we go and look in real time. It turns out that we do work with the Microsoft HoloLens out of the box. That's because the HoloLens is a browser-based tool. So we are browser-based software. So guess what? It works. It works rather well, in fact. So this vision can happen today, if that's something of interest to people. So our goals were, again, that automatic text entry and analysis. We've looked at automated voice recognition as well. That's, again, very doable through mechanisms like the HoloLens. We haven't gotten there yet fully. Again, that mixed reality entry, again, is another place where I think we have done a lot of research there, and that's pretty far along as well. But definitely the simulation analysis of the standard operating procedures is here today. So measuring performance. Now, this was probably the big aha research item coming out of George Mason. They thought a lot about the problem and why we had the problem. Again, it's that variance of the times that particularly become important. So there's something they define as an allowable operational time window. That's the time before something really bad happens, right? And of course, you know that's a variance depending on where you are and what's going on, and particularly in an airplane, you can think it depends what altitude you're at. I might have a lot longer at 40,000 feet than definitely going to have a lot longer time to figure out what the problem is at 40,000 feet than I do at 10. So again, these are important things to be thinking about with that. But even then, there's a distribution of that time. So again, you want to look at that. What would that window be? And then the time of the procedure itself, of course, is something you need to calculate. And then again, that's a distribution, right? Again, as we've said, there's variance in the people capabilities. There's variance in how quickly they can execute. There's variance in all kinds of things. So, and then of course, now that what we want to do is look at that difference between the two. And again, these are distributions I'm taking a difference of. It's not single points. So I'm looking at these distributions, and so you can see now that I'm looking for where is it that it fails? Where does it go and become less than 0, which means I ran out of time. Okay, so that's what the analysis is doing. So so hopefully that's got everybody think about some questions if you have some about this. I'm going to move on, and we're going to do that in the Q&A. So a little more about how Sopatra itself works. As I mentioned, again, we are using NLP, natural language processing, that branch of AI, to do this work. And it's built on InnoSlate. And that was the best part, was we already had a very strong MBSE tool with a strong simulation capability, both discrete event and Monte Carlo built in. We could deal with the variances. So that's one of the reasons, in fact, George Mason came to us with this opportunity, because they realized we could do that. I mean, we could do it very quickly and easily. and we really did. We actually produced, if you're not familiar again with the STTR, the STTR phase 1 is 13 months. Well, we were done with the research part in 6. And we already had a prototype, everything working. We delivered the prototype, by the way, to the government, because that was done on their dollars. So we took the rest of the time of the 13 months because we couldn't apply for the phase 2 until we finished phase 1, right? So we said, well, what are we going to do with that time? Well, why don't we productize it and show that we actually can make a commercial product out of this? So we came up with the name Sopatra, which wasn't easy, by the way. we have a wonderful marketing department who came up with the name and the logos and everything. It was just fantastic. So and we were able to productize that in a very short time frame. And by the end of phase 1, we had our first release of Sopatra. So that's very unusual if you don't know about these programs. Usually it isn't until a phase 2E or 3 you see a commercial product out of one of these projects. So we were way ahead of the curve. Okay, so a little bit more about Sopatra itself. So again, the kind of things we're particularly looking at for the operator automation plant model. So this is the general model that we were looking at to understand what we're analyzing for a standard operating procedure and what we're doing. And of course, another term for this is human machine interface. You hear about that all the time, HMI. There are many terms for this, but fundamentally it's the same thing. We're looking at these procedures. How is it we're interacting with the equipment as people? Because that equipment's all for us, right? We're not building things for it themselves. We're building them for us. And so we want to interact with it. So the operator is an important part of the system. So you always want to make sure, if you're not doing good modeling, MBSE, you should make sure there's an operator in there somewhere. If there's not an operator in there somewhere, you probably are either at too low a level and you're working at the box level, or you really haven't really thought through the problem well enough. Because if you don't put the operator in your model, you won't have a good interaction with the human. Okay, so then again, we have two things going on: long-term memory, which is that knowledge, rules, and habits from training and experience. Those are great. And then as things go along, there's something called working memory. And what working memory is for example, a display might come up with a set of numbers. And so you probably write those numbers down quickly because they're going to go away with new numbers. And so you're looking for trends, or you're looking for something else. So that's a common thing to do. It's not unusual for a pilot to have a notepad strapped to their leg and where they take notes. That has been a common thing since, I think, almost beginning of aviation. So that's something you want to think about as part of this as well. Okay, and then there are different kinds of cues. So there's visual, oral, haptic cues from the environment and the plant. So these are things that you're looking for from it to understand, and that's what's coming in, and that's what the operator is reacting to, right? So those are coming from the output displays, and of course the operator is inputting things into the input devices, right? And then so that's your interface. There's your human machine interface, is the output displays and input devices, right? And then the automation part of it is the algorithms and things that are going on behind the software, the actuations of the equipment, and then that ties to the plant. So those are the commands to the actuators of the plant. So things like, I think everybody knows fly-by-wire. You're not actually turning cables anymore to change the flaps. It's a signal that gets sent to the flaps to change their position. So again, I think hopefully everybody understands this view pretty well of what we're going after, what we're trying to model. Okay, for Sopatra, our operational concept is we want to bring this information in, and we want the standard operating procedure, but it really helps to have some supporting documentation. Standard operating procedures often are very cryptic. They use acronyms a lot. They'll use special names for input and output devices. And another thing that George Mason came up with was a time distribution database. This is where they've done a lot of research and come up with distributions for how long it takes to do certain kinds of things, depending on how well you can see what's going on or not. And I think I have a slide a little bit later that goes into more detail about that. So we import that. We have a special importer we created in Sopatra. So if you're used to InnoSlate, we import all kinds of file types, but this one was something special we had to create to make sure we could take and convert that using the NLP algorithms into the model. So it does a pretty good job of that. I won't tell you it's 100%. Nothing ever is. You need to go through the model and look at the model carefully, adjust the model appropriately. It will auto number the model. You may want a different modeling number sequence. Highly recommend going in there and working with that. So again, this is a basic, get you out of paper into a model form where you can now manipulate the model. Don't expect it to be 100%. That's probably not reality anytime in the near future with anything. So even generative AI is, you've got to be very careful with, right? You're going to verify that it works. And we want to verify then the model itself. Once we have the model the way we want it, with the timing information, and I'll show you how that gets added and things too, then we can verify it, okay, using both discrete event and Monte Carlo capability. So we have the discrete event here showing in the first step. In step 3, I mean, verify. And then the analyze part really happens in the Monte Carlo. So what we're doing in there is trying to make sure the discrete event is sort of the bug checker, okay, for your model. So particularly if you have decision points and things like that in it, you can have all kinds of race conditions and things like that you're modeling and finding out where there's some significant problems potentially. I remember doing one of those for a missile defense system, looking at its SOP and or ConOps. Again, ConOps is another term we use. That basically the same kind of information. They have scenarios. You run a scenario. You find out that you need to violate causality to make it work. In other words, I don't have enough time to make something happen. And so that verification is also part of that. So you can see that as part of that early part, and then analyze. And then output, and then SOP outputs, and of course we have analysis products as well. So the SOP model data. So I mentioned that we have different formats of information. There's a Sopatra file group. It's actually it's available, and then InnoSlate itself. So again, it's you can bring stuff in from InnoSlate and then use it. We have some special classes of information. I don't know if I have a slide that gets into that in detail, but we have those boxes are not just the usual actions that we have in the action diagram. It's a procedure. So it actually has some special attributes and relationships in it as well. Then there's the Sopatra file group, which is, again, the SOP file. You have to have at least have that SOP file, or otherwise, why are you doing it? And then time distribution database. Okay, that's optional, and that's provided. We have that for you if you want it. And then for aviation, we have input devices, output devices, and acronyms. So these are all available for you if you're interested. I want to say we have it up on our digital curation station. I think we do, and if we don't, we should for you. But if not, you can always email us, and we'll be glad to get that to you. That's all open data that's available to anybody. So let's go through each one of the key things. So here's the file, the SOP file. Again, this is a standard sort of thing you see here. Again, pilot monitoring is a special kind of thing, right? That's a pilot who's monitoring, and then there's a pilot who's flying. So you have a pilot and co-pilot, and of course they change back and forth as things go on. So that you can see that through here. So lots of different. That's the actor in that case, and then the action is the verb in it. And so those verbs have specific things they're doing. So in number 3 here, pilot monitoring announces takeoff. So it's easy, right? So my actor, which is my asset in InnoSlate, is the pilot monitoring, and my announces takeoff is my action. Okay, so now I've got an easy way to break that up, and so I can make an action or a procedure step using the announces takeoff, and then of course assign it associated with performed by the pilot monitoring. So you can see how that would work, right? And so that's how we go through the document and parse it to start building the product. We also are looking for whens to indicate precedents, so we can kind of understand that. And again, as particularly as things get a little more complex, like number 5 here, pilot flying puts right hand on the nose wheel steering control and simultaneously keeps left hand on lap and simultaneously confirms my controls. Now that's a much more complex sentence that I've got to parse and think about that when and while phrases, so looking at those kinds of things to understand concurrence and precedence is all part of it. And then of course the step descriptions can be added as well. And again, we take more detailed information and make it available in the description field, or then using a note kind of thing. So, and then the IOs are produced from words surrounded by double quotes. So if you look at takeoff, you look at these things, takeoff, my controls, those kinds of things are indicators of something somebody said. That's an input to somebody else, right? So I'm saying that so that the other pilot, if I'm pilot monitoring, so that the pilot flying hears it and knows that occurred. Okay, so I think you can see how this works. So again, if you can structure the format, it makes it a lot easier for the parsing to work better. So we have a whole guide for that as well that came out of this. Again, that should be a best practice for standard operating procedures, which we couldn't find one, by the way. As we were looking out there for this kind of information. If somebody has one, please let us know. We'd love to see that and see if we can maybe adapt to that better. A time distribution database I mentioned. Here's the different fields in that distribution database. I think the most important thing, first of all, we're using triangular distributions. That's the best case, the mode, which is the average-ish of it, and then the max, right? So you have that min-max mode. So the primary, the highest probability would be mode, right? So anyway, so you have those 3 things. Now, what's nice about that distribution is there are no tails. Okay, so that's actually extremely useful in this kind of analysis, because the last thing you want to do is worry about tails of a distribution when you really want some more finite boundaries, and that helps you a lot. And by the way, if you're doing modeling simulation of anything, using InnoSlate or Sopatra, those triangular distributions are a great starting point, because we always have used engineering judgment to do a lot of these things. And what is that? Well, we kind of know how long it's going to take. What's the best case? What's the worst case? And what's most likely to be, right? Well, that's your triangular distribution. And so you can use that. I've used that over the years as well on projects. It's a very great starting point until you get better data to create a more complete distribution. And sometimes you never get better data than that. In fact, that's one of the things that they determined with the work that they were doing at George Mason, was this was the best form that could be done. And then in the queue evaluation, again, there's no queue. Okay, that's long-term memory. So if there's no queue, that means you've got to have something in long-term memory that makes you realize you need to do that step. It's not in the field of view. Okay, that's a big deal, right? You want to make sure you can see stuff, but if you have to turn your head or you have to go somewhere else, you may have to do that And again, might take you longer to realize you need to move your head and look somewhere else for that cue. And then in the field of view, we got three in the field of view, different types of things. One's not salient, and in other words, it's cluttered and lowest in noise. And then there's salient and ambiguous semantics. So in other words, I don't quite understand what it might mean. And then the last one, salient and unambiguous. So again, that's the one you hope it is. It's in the field of view, it's salient, it's unambiguous, and there's plenty. The semantics are obvious. That's what you're looking for. The other thing that you'll see is frequency. So how often do you see this kind of event? How often does a problem occur? And so you could track that as well. And again, if you in this, we have some data source suggest capturing your data source as well. So again, this is something that can be built, and they're stored in the database as equation entities. We have an equation entity type in InnoSlate, so that was so it's viewable there as well. And if I didn't mention this earlier, the two tools work together, and in fact, we provide a version where you can go back and forth between the two. There are reasons. The reason we tried to simplify the user interface in Sopatra was we were told that a lot of the people who develop the SOPs are operators, and they don't want to be systems engineers. They don't care about systems engineering. Come on, they're operators that try and do the job, and so we wanted to give them as simple and easy interface as possible. So that was another part of the breaking out that piece. Input devices. So again, input devices, all kinds of different things there. It is case sensitive, and you need to include both the singular and plural forms for it to find things. So again, that's a lot of it. I think that's probably the most I want to say about that one. So I realize what time it is now. Output displays, very similar kind of thing as the input devices. And this helps us determine where it belongs. Where does it belong on the line? And then acronyms. So acronyms help us transfer stuff. So very often that pilot flying is just an acronym. It's PF, and there's no way there's an infinite number of acronyms you can come up with. So how do you know that's the actor? It could be something totally different. So again, you want to have some kind of indicator to help you understand what you're looking for. So better if it's spelled out, but again, the acronyms list there in case it hasn't been. So the importer. So we have an importer. Again, I mentioned that we had a special one we created for this. You can start with an existing process, or you can create your own. The little plus button right there beside it means I want to create a new one, right? Yeah, okay, good. And then when you do that, it then pops up this display underneath it where you have the SOP tab, there's a time distribution tab. So these are imports for each of the different types of things we just went through. So obviously you have to start with the SOP file and get that in there. You only have to upload the time distribution, input devices, output devices, and acronyms once, by the way. So that's a little feature. So if you bring in new SOPs, you wouldn't have to do those. It can reuse that information. So then upload the SOP file by dropping it in, and of course you get the normal thing for InnoSlate. You'll see the save button, hit save, and then go through and do the other ones. And now finally, once you're there, there's some options you can look at for the execution options, but basically now it's time to run Sopatra. So running Sopatra gives you something pretty significant sometimes. Now we add a step for each one of these. We specifically pull out a see here and decide step. We create one for every action. The reason for that is you want to apply those time distributions that are in that database mostly to these see here and decide actions. As you saw, field of view, things like that, salient, all that stuff is part of that see here and decide. So it's again considered a best practice to do that. And so this auto generates those for you. So this actually is a little busier than maybe it would be if we didn't auto generate those, but this lets you separate the time it takes to make a decision to actually then the time it takes to perform the action. So this gives you both. And again, it's a best practice. I already kind of hear in the back of my head that people are saying, well, what if I don't want that? So we are looking into that too, by the way. So we're looking for that kind of feedback. Is that something you'd like to see us remove? We think it's important, but if you don't think it's important, hey, you know, it's a commercial product. We got to go with what the customer wants. Okay, so the Monte Carlo output looks like this. So again, this is running 1,000 iterations. You can pick whatever number you want of iterations, of course, to run. And you can see with this particular scenario, again, having done a lot of work with the other one, that cleaning it up and making it look nice and adding in the timings and all the other stuff. There's a lot to do there. So anyway, you see the different distributions, your TOP bar chart, the blue one there, the orange is the AOTW, and then you see the overlapping of the two probability curves, you know, there in the bottom left. And then in the bottom middle shows me that scatter plot we saw on the earlier slide, where we were looking at the two distributions and then the scatter plot. So you can see some of the red dots. And the red dots are indicators that it is failing in those situations. Again, there are outputs you can create from this to see which situations are failing and that kind of thing. And then, of course, your PBT bar chart as well on the right. Probably one of the most important things is that though panel I skipped over at the very front, the status panel. That shows me my means and my standard deviations for each of the items. And there's an input of a criteria level. So if I can accept that 5% of the time it doesn't work exactly, that's what that number is. You may put 0 in there. You may say, hey, no, I can't have it ever fail. And then that's fine to put that in. But so all that will do is change the color of the fail rate at the bottom. So in other words, if the fail rate, if I had set that to 0, that fail rate would look red instead of green. That's the only real difference. So anyway. So we have time for a quick demonstration, and I'll hit a couple of quick highlights with it, and then we'll have time for Q&A. Okay, so here's Sopatra, and this is the dashboard for Sopatra. Now this is a standard dashboard for Sopatra. You can add some widgets, but not many. It's not as many as we have for the other for InnoSlate. So just so you know, if you're expecting that, that's not going to be here. Again, you can see the exact same database using InnoSlate and set it up any way you want as a systems engineer. So this lets, again, we have now a tool the operators can use to help develop these and analyze these SOPs. But then we also have one the systems engineers can use to help do more in-depth analysis. And that's the whole idea. So here, once you've selected one here, I've selected this particular one. It shows me that I have the SOP, the time distribution database loaded, input device, output device, and acronyms are all loaded. If I scroll down here, I see a picture of the image, and I go right to the diagram itself that was generated. Now, I will tell you, I did a fair amount of cleanup of this, so don't expect it to be this pretty. But you can see it's pretty busy. there's a lot to it, and you can, as you get to different levels. And by the way, again, since at any resolution, you can select items and see on the sidebar what it is. So again, you don't necessarily have to read everything if you want to get the bigger picture, and you just kind of click through and see what the things are. And they show you where we've got derivations as well. So, or you could say that, you can put that in there. Okay. Now, here's where we get these things that are on the distribution database, the TOP. So it's TOP, AOTW, or event. So in this case, it's a TOP. Back to TOP. And then a frequency of always. Again, you can select which ones you like. And it unselects it if you select it twice, obviously. And then here's your field of view cues, not the field of view. And then there's a start time. If you, again, this is for, because actions have that. So this is an inherited value. And then the duration is input here. Now, again, this is a procedure, which is a subclass of the action. And there are some labels for this. This is some advanced work we were doing, looking at something called EPRL, which is a language used by NASA. And so that's what those are in there for. You probably can ignore those. And then, of course, you can go look at relationships. And my favorite is active. So you can see who performed it, the input output being received in this case, and the parent, which is the parent of the whole thing. Okay, so again, very nice. Now, for the time distribution databases, when you want to add them, all you have to do is go click here and select from it. And this has a specific one that's already there. So that's what I would select and use. And that is the value that's already there. So that's what was done for that attribute. Put this time distribution database. One of the nice features too, though, and this is true in InnoSlate as well, you can multi-select and use this item to apply the distribution across the board if you want. So again, if you don't want to go through the process, the very long, lengthy process actually of selecting all those attributes, we get it. You can do, there's a quick shortcut. So you can go through, and particularly for some of the other ones where you don't care so much, or you want them to be 0, or you want them to be just 1 second or something in this case, you might want to use that multi-select capability to do the timing. Okay, and then once you have it ready to go, you can simulate it again using the discrete event or the Monte Carlo simulation. And so let's just cut to the chase, and I'll do a Monte Carlo. I won't do 1,000. I think I did stop it. Here's where the settings are. So you can set it to wherever you want. Here's your desired PBT. So if I say I want this to be 2%, let's do that and leave it that way. And so now it's running through that model 100 times with different seeds for the distributions. And this all runs in the browser, by the way. So it's running on your computer locally. And so you can see what we get. So the fail rate came out to 6% in this case. And so this is why you want to run a lot of iterations, by the way. You want to refine it and get a better number with the longer time. The more complex it is, the more iterations you need. Probably for something this complex, I'd probably run 10,000 at least to look at it. But that takes you too long to do in a demo. So anyway, so you can tell this is a way that you can now link this together. Any outputs you want to get are right here. The reports are available through that mechanism, including there's a whole sim report here that's available. So these are things helping you, both the image and a report. So this gives you the numbers, the distributions. Okay. So I hope this helps everybody kind of get a quick look at Sopatra. We're happy to give full demonstrations as well, where we can dig more deeply into the tool itself if you'd like. So that's available as well. It is also part of our support package, so we do provide the support for this, and we really want to make sure we're here to help you. So let me do one more slide and then get off the stage and do here for Q&A. And so again, the two together really help you do a more complete analysis of your standard operating procedures. So this is why if you are thinking about Sopatra, get at least 1 or 2 copies of InnoSlate 2 so that you have that ability to go in there in depth and do other things. Currently, we don't have a full output of the SOP, partially because that's actually more complicated than you might think it is. But you can use the reporting mechanisms in InnoSlate to help you get out that way to textual output. We are working on that report and should have that hopefully sometime next year. I guess unless there's higher priority by customers. Okay, so again, sales is available and support, so you can contact us if you'd like a demo copy of the tool, access to it. That's available as well. So again, you can test it before you buy. And then I think we've got about 9 minutes for Q&A. So do we have some questions, Liz?
Thanks, Steve. We do have a few questions already. If you haven't done so, please send your questions to the panel on the right that pops up after clicking Q&A on the top bar. He will answer as many questions as he can before our time is up. Our first question is, how can we get access to Sopatra?
Yes, so actually, again, go to you can just go to the specinnovations.com website, and there's a Sopatra tab for it. You can go and look there, and they go ahead and set it up. So I can probably show that really quickly. Go to the spec site. Oh, by the way, if you want to know more about those flights, this is the paper. I just caught it just before we came up, and I'm sorry, I thought I had it right here. Yeah, here's the help center. So here's our main page, and here's Sopatra. Just go there, and you can sign up. I'm sorry, my HubSpot indicator does that on top of it. But anyway, you can. That it popped up with our thing here. So, and once you sign in, you can sign in from here, or you can go to sopatra.innoslate.com as well. But yeah, you request a demo. I think that's your best starting point. We have tremendous resources on our website, by the way. So do please look at the website. There's been a lot of work put into it recently. If you haven't done it in a while, a lot of really good work recently that's made it even better. So. Next question.
Our next question is, what are some of the possible improvements you are planning?
Yes, so one of them is definitely the report output. I want to go through and have a logical way to do that output. You got to think about that. Again, it's a more complex problem than you realize. You think it's something that's simple input output thing, but no, you got to go through and recreate the sentences and then put them out in the correct order. And what is that order? Is it the numbers that the user put on there, or is it some other order? If the user might have made an error, again, because we can analyze the triggers. So you can see it's a little bit more complex than just simply a simple output. Another is, again, exploration of generative AI. And seeing it, a lot of people are creating diagrams directly using generative AI. Different kinds of diagram types and things like that. So there's no reason we can't do the same thing and look into that. But again, our customer base is very security sensitive, as frankly almost everybody is these days. And cybersecurity is extremely important to us. So we want to make sure when we have a solution, we can put behind the firewall. And so we are working on that right now. And we think we have a very good relationship with Ask Sage, who is developing that behind the firewall capability for all kinds of GPTs. So very exciting. So those are some of the things we're looking at. But again, we're very customer driven. So your suggestions and inputs are always welcome. And we really do turn those into product. So please feel free to ask us for things.
Great, thank you. Are you considering using generative AI instead of just NLP?
Yes. I think I mentioned that before. We really probably will have to go there, but until we're in a secure environment with it, we just can't put the time into it to put it up and use it as part of it. We are researching it and using it. It is in a slate on the cloud. It is available there right now, but and it's an organization by organization availability to it. It's in our open platforms for academia to use and experiment with, but we really want to be very, very careful with how we use it.
Thank you. Our next question. Yep, we have time for one more. Is verification Monte Carlo a direct correlation to Monte Carlo simulations used within Microsoft Project?
Oh, okay. I'm not that familiar with what Microsoft Project uses for it. I think it's Crystal Ball. That's what they used to use in conjunction with it. It's very similar. It should be the same kind of thing. It's Monte Carlo's kind of Monte Carlo. That was an analysis developed at Los Alamos National Laboratory back in the 50s. And so it was used in nuclear weapons design, and it's been applied in many other techniques. But Monte Carlo is pretty standard technique. So I imagine it's about the same.
Thank you. That looks like all the questions we have for today. We would like to thank you again for joining us. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for our next month's webinar, Product Lifecycle Management plus Model-Based Systems Engineering is Better Together. Your link to sign up will be in the email that is coming soon to your mailbox with the slides and recording. We also encourage you to visit our website, our blog, and our blogs, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day, and we hope to see you at our next webinar.